Alright guys, so I got sick. So I'm going to make 2 videos real quick. Have to keep it under 15 minutes. So it's for each one. So we're going to be kind of rushing a little bit. So we're going to look at logarithms. So we're going to start off by remembering that in Algebra 2 you learned about exponentials as we've been going through. And logarithms are their inverse. It simply means what I have here drawn in orange is the table on the left. The purple points is just representing the line of reflection that makes an inverse called x equals y, or you call it y equals x. It's the same thing. So to make an inverse of an exponential, you would flip all the x's and the y's because it reflects over the equation x equals y or y equals x. So it would look like this. All right, so once I flip the position of the x and y's, I'm going to graph them. And a logarithm has a vertical asymptote, that is y equals 0. So it will not pass the y-axis. All right, so that means this as an equation can be written as a logarithm, that is y equals log base 2 of x. And you'll see what I mean below when we talk about conversion. So for logs, we have the exponential form, y equals b to the x. And once again, to reflect, to make the inverse of exponential to log, you're reflecting across the line y equals x, or you can call it x equals y, because it's the same thing. And so the position of the x and y switch positions. So the x is now here, and the y is the exponent. But then to write it in its log form, we have, you can see kind of the letters move. The log ends up being equal to the exponent. What I like to call the result goes right here, and the base of the exponential is the base of the log. And I'll label that below in a little converting example. So log base 3, so that log base 3, that's called our base. You can see the positions they're in from log and exponential. This is what I like to call the result. The 81 goes right here in the log, but in an exponential, it's what it equals, hence the result of the exponential, if I could spell exponential right. There we go, result. And then you can notice that the logarithm is equal to the exponent. So when we're converting, we want to make sure we know the proper positions of everything. All right, so since log base 10 is the most common logarithm, we tend to not write it. So if you have log base 10 of b, it's really just log b, and you have to remember, like, hey, that's a base 10. Since exponentials and logarithms are inverses, that means they can cancel each other out. So if we have, so as an example, if we have log base 10 and its result is 10 to the 5th power, well, since the base 10 and the result has a base 10, those are opposites. Okay, so they're going to cancel each other out, leaving an answer of 5. You could also write it as, well, if you have a base 10 and its exponent is log base 10 of 9, well, then the log base 10 and the 10 is going to cancel each other out, leaving 9. So you can see different ways we could use that idea of canceling to help us simplify to an answer. All right, it says write each form in logarithm. So as an example, I'm not going to do all these. Once again, this is the base. So when I write the log, I'd write log the base of 15. It's going to be a subscript. Then I have my result. Which was in this color, result. So that's going to go here, 3375. And then the exponent is what the logarithm equals, which would be 3. So in this one here, this would be log base 4. The result is 2, and it equals the exponent. And you've converted it into a logarithm. All right, so this is asking us to simplify. So we have log 10 to the 3rd. Remember, that's really log base 10 to the 10 to the 3rd. And since these are inverses, they can cancel, leaving the answer as 3. All right, and then our other one asking us to simplify, we have we have log 10 to the x times, I'm going to rewrite this 1000 in base 10. So 10 to the 3rd power is 1000. And then I can simplify it by using my property of exponents, where if you have the same base and you're timesing, you add your exponents. So this is really log base 10 of 10 to the x plus 3. Once again, since we don't see a base value written here, it's really 10. These are inverses. They cancel, leaving x plus 3. In this one here, using our property of exponents, when you divide, you subtract the exponents. So this is really log 10, 1 minus 5. And so this is really log 10 to the negative 4th. And once again, since this is truly log base 10, these are inverses. They cancel, leaving negative 4. So here, I'm just going to show one of these because we're going to use the calculator to help us. It says use the calculator to write the following in the form of 10 to the x, where x is 4 decimals. So basically what it's trying to say is x is 8 is equivalent to 10 to some exponent. Well, this is where we kind of use that canceling out type property, or the property to help understand that we can get an 8 here by saying, well, 10 with an exponent of log base 10 of 8, which means these would cancel out, giving us 8 is equal to 8. But they want our answers as 4 decimals. So what they're asking us to do is to rewrite this as a decimal. And I'm going to show you how to do that in your calculator. So what we're really trying to figure out is 8 to the 10 to some decimal. So to do that, we're going to go ahead to our calculator. And the way we get logarithms in our calculator, we hit the math button. We're going to go down to log base. There it is, log base. Hit enter, and we're going to hit the base 10, and the result was 8. We hit enter, and it tells us its exponent should be 9031 when we round to 4 decimal places. 0.0931. And that's really what they're asking for. It's just there to get practice with the calculator. So here it says evaluate and correct to 2 decimal places. Once again, this is a calculator problem. We go back to our calculator, we hit the math button. We go ahead and get to log base, hit enter. It was base 10 because you didn't see a base written, and the result was 110. And therefore, it will tell us 2.041. They want 2 decimal places, so 2.04. So as a reminder of how this makes sense, remember, what this is trying to say is 10 to the exponent of 2.04 is 110. We're going to skip this. It's not really important. So this last one right here, we have a magnitude of earthquake which releases E joules of energy, and they give us an equation to represent that. It says find the magnitude of the earthquake when releasing this amount of energy right here. So this is our E, and they just want us to plug it into the equation. So A is equal to m2 over 3 log 5.1 times 10 to the 10th over 10.48. And they want us to type it into the calculator, and I will show you how to do that. So we're going to make the fraction 2/3. Then we're going to go ahead and hit the log button by going ahead and going to math. We're going to go to log base. And we're in base 10 because they didn't write a base for us. We need a fraction. And it was 5.1 times 10 with an exponent of 10. And in the denominator, it was 10 with an exponent of 4.8. Hit enter, and it tells us the decimal of 3.94. 3.94. All right, part B is a little more complicated, and I'm going to show you how to manipulate the equation and all that kind of stuff. So this time they're giving us the magnitude, and they want us to solve for E based on whatever that magnitude is. So I'm going to do that over here. So the m of the equation is going to be 4.3 this time, and that equals 2 over 3 log E over 10 to the 4.8, and they want us to solve for E. So this time I'm going to get rid of the fraction by multiplying both sides by its reciprocal. This is going to cancel out, and 3 over 2 times 4.3 is going to give us 6.45. Right? Then I'm going to go ahead and rewrite my fraction here on the right. So it is log 10 to the negative 4.8 e equals 6.45. Now I want to get rid of the log. So what I'm going to do, I'm going to go ahead and bring everything to base 10. So I'm going to multiply base 10 to everything, which means if this is truly log base 10, these are inverses and they cancel, leaving 10 to the negative 4.8 e equals 10 to the 6.45. From there, I'm going to get e by itself by dividing both sides by 10 to the negative 4.8. And then e equals, in this case, when you type 10 to the 6.45 divided by 10 to the negative 4.8, you get something in scientific notation. So it's going to be 1.778 times 10 to the 11th.